Welcome, my dear JEE 2026 students, all the 11th moving 12th students. It's time to save your 12th by covering all the essentials, all the important things which you will be needing for your 12th standard, which are dependent on your some of the 11th standard portions. So, this amazing 3 days, which will cover up your majority of your backlogs for your upcoming 12th classes. Welcome, guys. This is your Captain Shreyas, your physics master teacher on the Vedantu JEE English channel, the #1 JEE English channel in the country. And here we are yet again to start the next year preparation for 2026. And already you have seen how we were involved in the JEE 2025 preparation. And I'm so excited to see all of you and all the new students. Welcome aboard. Hi Kishore, hi Yogesh. Yes, we'll be starting some new series. Yes, Isagi, welcome. Hi Ali. Hello everyone. Stephen, Jan, Raz. Good evening, my dear students. It's time to begin the class and we will start with just 1 second. Yeah, there we go. Okay, then we'll start with some concepts of vectors, Newton's laws, energy, and how to use these vectors and kinematics and all these things. I will help you out with, because you will see it will start from chapter number 1 itself of your 12th standard. And if you are not aware of all these things, then you'll be like, okay, wait, I forgot about this. Wait, I don't remember that. All these things will happen. So that's why I want you to be up to speed so that you do not feel alien to class 12, else you will be lost. Okay, so thank you for smashing the like button. If you have not yet done that, mark it. Okay, smash the like button, and of course subscribe to the channel. You're going to need me, the entire channel, for the next entire year, right from the preparation to the strategies to the counseling. Okay, everything on this channel. So let's go, guys. Good evening, Jan. Hi Thania. Hi Kirtana. Hi Tarshan. Hi. Good evening. So we all probably remember what a vector is. We'll start off with there is no chapter-wise sequence. You will see how I conduct the class for your backlogs. It will be a very power-packed session. So a vector always has magnitude and direction. We all know this. A vector has magnitude and direction, and it's not just about it. It also follows the laws of vector addition. It also follows the laws of vector addition. There are plenty of examples of vectors, right from displacement, velocity. Speed is not a vector. Velocity, acceleration, force, field, you will see. Yes, momentum, and so many other things, torque, angular momentum, etc. Just keep a note of this. Although current has both magnitude and direction, it is not a vector. It is not a vector. And the reason for that is because it doesn't obey the rules. It doesn't obey the rules of vectors. Doesn't obey the rules of vectors addition. Doesn't obey the rules of vector addition. That's the problem. So say for example, I have 3 amperes of current and 3 amperes of current. It's not that the direction will matter to see what the resultant, the total net current will be, irrespective of whether the 3 amperes and 3 amperes comes like this. Totally, when you bunch them together into a single wire, you will get 6 amperes of current. So it behaves like a normal scalar. That's what you should keep in mind. Yeah. Oh, definitely. I'll come to Trichy. I'll be coming to Chennai on 6th of May. So make sure you're filling up the forms. The links are there in the description box in case you have not seen that. Yes, this kind of link will be there. So click on this particular thing and you will be able to see the form. Just fill up this form with your name, contact number, grade, and your location. Will be coming for your career counseling. This is especially for 2026 aspirants only. Whether you are JEE or NEET aspirant, doesn't matter. You will be getting to meet me and the entire team. Yeah, right over there. Okay, so please fill that up. Now, this obviously we know is nothing but the tail. This is nothing but the head, and we also know that the length of this is the magnitude. The length of this is basically the magnitude. More the length, more the magnitude. Magnitude and direction. Direction is given by where the tail to head direction is, the where it is pointing. And any vector, generally we use this symbol like a bar, or the tail is, let's say, O point, head is, let's say, A point, then a vector is from O to A, right? And if I put a bar modulus, then it means the length of the vector. Basically, I'm talking about the magnitude of that particular vector itself. Yes, that's how you represent vectors. Now, there comes a point where you need to add vectors or subtract vectors or multiply vectors, but you can never divide vectors. It is not defined. It is meaningless. There is no physical quantity which behaves in a way that you might need the division of vectors. So that is why you do not define division. So there are many vector operations. Let's just concentrate on addition for now. And whenever we talk about the vector addition, there are multiple ways of doing so. Main thing that you should know is there is a geometrical way, there is a geometrical way, there is a geometrical way, and there is a formula or analytical way. There is a geometrical way and then there is a analytical way. So what is this geometrical way and analytical way of vector addition, and what does it really mean by adding of vectors? I'll give you a simple example. Just imagine, my dear students, there are two pandus. What are they? There are two pandus, and these two pandus, this pandu eats two idlis, and this pandu also eats, let's say, for example, five idlis. So if I ask you, what is the total number of idlis, that the pandus had, what will your answer be? Come on, my dear students, what is the total number of idlis the pandu had? Yes, definitely we will be having a series for the long term. Don't worry about it. Concentrate on the class for now. Let's save your 12th before entering into the 12th series. Yes, the total number of idlis is nothing but 2 plus 5, which is nothing but 7 idlis, isn't it? The total number of idlis is 7 idlis. It's just a simple scalar addition. Now what happens is, there was a champa who was passing by. Yes, there was a champa who was passing by. She was going in a car. Like this, and the champa's car broke down. So there is a beautiful champa over here, nice hair, and champa is sad because her car broke down. So what these pandus do, pandus offer help to champa. They are like, don't worry champa, we will help you. So imagine this pandu, because he has eaten 2 idlis, he applies a 2 Newton force. This pandu has eaten more idlis, so he applies 5 Newton force. So what is the net force in this case? What is the net force in this case, guys? What is the net force in this particular case? Both of them are helping each other, so it will be 2 plus 5, which will be 7 Newton. But imagine a scenario where that same Champa's car has broken down, but this Pandu, who has eaten 5 idlis, is pushing from the front, applying 5 Newton. This Pandu, who has eaten 2 idlis, pushes towards the back by applying 2 Newton force. So in this case, what is the net force or the resultant force or the cumulative force or the the whole effective force which will be there? Obviously both of them will partially cancel, not completely. So it will be 5 minus 2, which is going to be 3 Newton. Isn't it, my dear students? So what it means is that over here, as you can see, force 1 and force 2 together provides the net force, but you cannot simply add them. This is not true. I cannot say that 3 is 5 plus 2. No, 3 is not 5 plus 2. Sometimes, when the vectors add, they might cancel. What if they were at an angle? It will neither be 7 Newton, it will neither be 3 Newton, it will be something else only. So F1 and F2 together, I cannot just add them to get the net force. That is incorrect. So rather we put this as the symbol to express that, listen, there is a directional effect also which you need to consider. So when I put a bar, it does not mean that I'm adding the magnitudes. It means I'm adding considering the magnitudes and the directions both, because both of them matter to find the net force. So that bar signifies there is vector addition involved. Is that right, everyone? Yep, clear about this? Very good. So in geometrical method, if you notice, there are multiple ways. One is the triangle method, the second one is parallelogram method, and the third one is basically the polygon method. The polygon method. In analytical, there is basically, you can say the formula method, and the next one is basically the component method. So just to give you a quick recap of what these methods were. Yep. So if you have, let's say two vectors like this, one vector is here and another vector is here. Let's say I call this vector A, and let's say I call this vector B, and I want to do this. A vector plus B vector is going to give me the resultant vector, which I'm going to call it as R vector. This is sometimes called as the net, or the total, or basically the effective, or basically the vector sum, whatever. Okay, whatever you want to call, or you can also call it resultant. All these things are the same thing: net vector, resultant vector, total vector, effective vector of these 2 or 3. So that is what it is. So if you take these vectors, let's say for example you take this vector and you take this vector. If you use triangle law, make a triangle. How? First take any one vector as it is, take the second vector, but such that if the arrow is here, the next vector's tail will be there. Like this. Now you have got basically two sides of a triangle. Then what you do is just draw the missing side starting from the tail and going towards the head. That is going to give me the resultant force. So if one Pandu applied A Newton of force, other Pandu applied B Newton of force, the total force when they are at an angle will be R Newton of force. So you can replace these two forces with one singular force, which will behave like the cumulative effect, like the total effect of these two individual forces. That is what the meaning of resultant is. This method of addition, where you draw the missing sides of the triangle and then join the remaining side, this is called as the triangle method. Where the tail coincides with the head and the missing side starts from the tail and goes to the head. The other method is both the tails are together. Yes, take both of their tails together. So this guy's tail is here and this guy's tail is, let's say, over here. So this is basically A bar, this is B bar. This is now the parallelogram method, where both the tails are joined together. Now you complete a imaginary parallelogram. So just draw parallel sides for making a imaginary parallelogram, something like this. Now from the same common tail, complete the diagonal. That's it. This is your resultant, my dear students, and this is then called as the parallelogram method. This is the parallelogram method of vector addition. Is this all right, everybody, till this point? Now, if you notice, whether you do it like this or like this, you still get the same thing. It is got nothing to do with it. Okay, which method you use? Also, keep in mind, A bar plus B bar is the same as B bar plus A bar. So the order does not matter in which order you conduct these additions. First plus second or second plus first, both are the same thing. It is a commutative law. Okay, great. Awesome. Perfecto. Sir, I'm doing Cambridge A level as a private student. Do you guys teach for that? If you can let me know what exactly is the syllabus, maybe we can cross check and then we can let you know whether it is matching. But otherwise, I'm not really sure, because there are some one-to-one classes also which we conduct, private classes. So maybe there could be, separate set of teachers for that particular syllabus. So if it is there, I can let you know. If you can just keep a comment after this video, or just message me on my Instagram or Telegram, same handle, captain_Shreyas. Okay, that will be great. Okay, now the another way of finding the resultant of both of them is, if I know, and by the way, this is the analytical or formula method, the formula method. See, both of these vectors together have certain angle between them. The angle between them is theta. Now, do not ever measure the angle like this. This is not the right way of measuring the angle. Always, whenever the tails are joined together, this is the correct angle between the two vectors. So when A and B are like this is not the angle. In fact, if you extend this over here like this and you measure this is the correct angle between the two vectors. Always, to measure the angles, slide the vectors such that their tails or their heads are coinciding, and the included angle is the correct way of measuring the angle between any two vectors. So if you know that included angle, then the resultant is given by, observe this formula, you have a square, then you have b square plus 2 times a times b times of cos theta, the entire thing under the root. This is the formula method where you don't draw anything, just a and b are given and you immediately can find out the resultant acting on it. Okay, so this is the way you add the vectors via triangle, parallelogram or formula method. Now these methods are usually used for two vectors. As you can see, every time there are 1 2 1 2 1 2 two vectors you want to add. But when there are more vectors, then you use polygon method, or basically the analytical, that means you solve and get it, the component method. We'll discuss both of them. Okay, so say for example, you have vectors like this. One is vector A, one is vector B, one is vector C, one is vector D, like this. Okay, Chuma, I have taken some random vectors A bar, B bar, C bar, and let's say D bar. Okay, I want to add all of them. So A bar plus B bar plus C bar plus D bar, that will give me the resultant vector R bar. So polygon method is very similar to triangle method, but just that you need to keep on repeating the process till you get a missing side of the polygon. So start with any vector, doesn't really matter. Let's say you start with A vector, it is like this, and then you go to B vector, let's say it is like this, then you go to C vector, and then you go to D vector, and then you go to D vector. D vector is something like this. Okay, so after doing this, you will notice that there is a missing side of the polygon. This was A vector, this was B vector, this was C vector, and this was D vector. There was a missing side of the polygon, and that missing side is basically this. Can you see, my dear students? This was the missing side of that imaginary polygon. So that is basically your resultant. That is basically your resultant vector. That is basically a resultant vector. As simple as that. Is there a direct formula like before when you have more than two vectors? The answer to that is definitely a no. The answer to that is definitely a no. But like I said, there is a analytical method, meaning the component method. And what is that component method? We'll talk about it now. But before going to that, let me remind you, whenever you have vectors, you can represent a vector something like this. Say you have a vector like this. This is, let's say, my vector V. This vector, I can split it up into two parts or three parts, depending on whether it is a two-dimensional or three-dimensional problem. What is this necessity of splitting? See, if I tell you one person is there, he's walking 2 kilometers north, 3 kilometers east, 5 kilometers south, then 2 kilometers east, then 7 kilometers north, then 3 kilometers west, then 1 kilometer north, then 3 kilometers east. So solving this kind of question is easy as compared to he's going southwest, northeast at 40 degrees, 20 degrees, this degrees, that degree, how much distance has he finally traveled? This is a slightly difficult question. So it's always better to split up any vector which is at an angle into two parts which are mutually perpendicular to each other, which we call it as the components. What do we call it as? We call it as the components. So the components of a vector, my dear warriors, if you have any vector, I can split it along the x-axis, y-axis, and even the z-axis. So now this is a two-dimensional figure. So I'm splitting it into two components. This is the x component of it. This is obviously the y component of it. And the total vector is a combination of both of them together, or this vector can be split into these both components, can be split into the x component and the y component. It is the sum of it, or when you split it, these are the two parts of it. So I can call this as the components of the vector. I can call it as the components of the vector. And this vector then can be written down as like this, something called as Vx, Vy, and then you have these special terms over here, unit vectors, they are called I cap and j cap. Whenever you see that cap or that hat, it means it is a unit vector. What did I say? Whenever you see a cap or a hat, what does it mean? It means it is a unit vector. So a unit vector, my dear students, is a vector whose magnitude is 1, whose magnitude is basically 1, and it is represented with a hat. It is represented with a hat on the top. So if you take any vector and I put a cap, 100% the modulus of that will be 1. Any vector, let's say some r vector with a cap, the modulus of that will be 1 because it is a unit vector. There are special 3 unit vectors which are along the x-axis, y-axis and z-axis. So if these are your x-axis, y-axis and z-axis, the special unit vector whose length is 1 pointed in the x direction is called I cap, pointed in the y direction is called j cap, and pointed in the z direction is called as k cap. Is that right? I, j, k are special unity vectors whose length is 1 and pointing towards x, y and z respectively. We use this to write any vector in I cap, j cap form. So this vector Vx bar is I cap like that, Vx times, so I cap into Vx, and Vy bar is j cap, how many times? Vy times. So this over here is basically j cap. So this is how you usually represent any particular vector, and whenever you want to find the magnitude of this, so if you take the mod or if you just write V, that will be always be equal to take the x component square, take the y component square and put it inside the root. That is going to give me the magnitude of that particular vector. That is going to give me the magnitude of that particular vector. This particular way of writing is called as representing a vector in unit notation. Representing a vector in unit notation. So if you take a simple example, let's say I have a vector like this, 6 I cap minus 8 j cap. 6 I cap minus 8 j cap means, say for example, this was your x-axis, this was your y-axis. Okay, Shubha, I'm taking some random example, x, y, this was your origin. 6 I cap means you take I cap 6 times. Means you take I cap 6 times. So this particular thing over here will be nothing but 6 times of I cap. 6 times of I cap. This is negative 8 j cap. That means j cap usually is in the y direction. Negative j cap means in the negative y direction, but 8 times. So this much over here is basically minus 8 j cap. So the total vector which we want, is basically in the fourth quadrant, something like this. So this is actually our vector v. This is our vector v. It is somewhere in that southeast direction. Now it becomes easier to represent any vector. If somebody asks you what is the value of this particular vector, you will just take the 6 value, square it, take the -8 value, square it under the root. So 6 square is 36, 8 square is 64. So 36 plus 64 is 100. Root of 100 is basically 10 units. So the answer is the length of this is nothing but 10 units. Is this absolutely clear? Yep. Every vector has a unit vector. Yes. Every vector can be written down in its unit vector form. Always. Always. You can always write any vector in the unit notation. Something in east direction, something in north direction, something in up direction, something in down direction, something in west direction, something in south direction. So always you can write it in I, J and K form. What will be the difference if it was a three-dimensional vector? It will be Vx I cap plus Vy j cap plus Vz k cap, and this will be Vx square plus Vy square plus Vz square, whole thing under the root. That is the only difference. So say for example, my dear students, say for example, if I tell you, listen, I have a vector A which is A hat, something like this, 0.2 I cap plus 0.3 j cap plus some alpha k cap. Question is, can you find the value of alpha? Yes, this is a three-dimensional problem, but the formula wise everything will be similar. Just one z term will come and one k cap term is coming over there. No issues. Now notice one very important thing in the question. As you can notice, there is a cap. A cap means it is a unity vector. So this is basically a unit vector. So the magnitude is 1. That means the modulus of this entire vector, which is 0.2 I cap plus 0.3 j cap plus alpha times k cap, the magnitude of this is 1. How do you find the magnitude of any vector? Just like mentioned here, magnitude of any vector, whatever that I cap, j cap, k cap is the component square under the root. Okay, so the components are 0.2, then 0.3, and then obviously alpha. Add them and put it inside the root, that is equal to 1. Square both sides, so you will get 1 square. Now 0.2 square is 0.04, 0.3 square is 0.09, and then we have alpha square. Okay, so 0.04 plus 0.19 is nothing but 0.13 plus alpha square is nothing but 1. Now take alpha square on one side, 1 minus 0.13 is nothing but 0.87. Therefore, alpha will be plus or minus both root of 0.87. So that is the right answer. Either 1 plus 1 or minus whatever, root of 0.87. If you substitute, the magnitude will be 1. It will behave like a unity vector. Is this point absolutely clear? Everyone? Perfecto? Clear how these things work for vectors? Just give me a thumbs up, and if you have forgotten to smash that like button, reminding you guys, please smash it right now. Very good. Further maths, economics and business studies in Cambridge A level. Okay, fine. I'll just let you know, Satya. I will just leave a comment. I will get back to you, reply to you on the comment itself. Okay. Now coming back to this particular problem, remember our essential problem of adding vectors. If you have two vectors, triangle, parallelogram or formula, which I just showed you over here, triangle method, parallelogram method or formula method. But when you have multiple vectors, you can use polygon or like the component method. So polygon method, I just showed it to you. What is that component method? It is very simple. You just take any vector and split it into components. So let's say a vector will have some ax I cap plus ay j cap plus az k cap. Same thing with b vector, same thing with c vector, same thing with d vector. Now what you do is basically you have to add them. Yes, you have to just add all of them. So the resultant vector the resultant vector, whatever it is, it will have some x component, some y component, and some z component, right? These components will be simple addition of these numbers. So ax, bx, cx, dx, whatever, I cap, I cap, I cap. So if you add this, you will get rx. Similarly over here, if you add ay, cy, by, dy, like that, you will get ry. Similarly, if you add az, then if you add bz, and then if you add cz, and if you add dz, you will basically get rz. Just simple addition will give you these numbers. So this is very easy once you know the components, right? What are these individual numbers of the resultant vector can be calculated in a much easier manner. Example, let me show you over here only. Say I have three vectors. Say I have three vectors. A vector is 2i cap minus k cap. Okay. B vector is, let's say, 3i cap plus 2j cap minus 5k cap. And let's say C vector is minus I cap minus j cap plus 2k cap, something like this. And we have to find the resultant of them. We have to find the resultant of them. Okay, how do we find the resultant? Just take these numbers of I cap and add them. 2 plus 3 is 5, 5 minus 1 is 4, so just 4 I cap. Is that right? 2 plus 3 is 5, 5 minus 1 is basically 4. Here nothing is there in j cap, so forget it. So you just have 2 and negative 1, so it will just be plus 1. So just plus j cap. Here minus 1 minus 5 is minus 6, minus 6 plus 2 is minus 4. So minus 4 k cap. So the resultant is this much. That's how you simply add using component method. Is that right, everyone? Yes, BitSat is coming this next week. BitSat is coming next week. Yep. Cool? Right. Okay, great, great. I hope till this point everything is absolutely clear. Now, how do you find these components, sir? I always get confused. Don't worry, I will teach you. There is a very easy way. There is a very easy way on how exactly can you find these particular components. Okay, so let's have a look at it. Let's have a look at it. Say for example, I have a vector like this. Let's say I have a vector like this, and I want to split it up into two components, one here and one over here. Now, see guys, let's say the angle which it makes here is, let's say, theta. Then the one which is closer to theta, this is not close, this is close. So this component will be V cos theta. This C stands for cos also, cos also. This C also stands for close. It's close. So it is cos, C for cos, C for close. Naturally, the one which is far away will become the sine component, or you can say the sine theta of V. And one way to remember it is, because this is far away, you have committed a sin. You have committed a sin. So think of it in a very weird way. Just imaginary things to just remember it. So far away, that's why sin. But somebody says, no, 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 for me, this is the angle. And he says, this is my angle phi. So for that person who measures the angle with respect to y-axis, this phi is closer to this component. So this will be close. That means this will be V cos phi. And this one will be sine, because it is far away from that angle. So this will be V sine of phi. Let me show this to you with some simple examples, my dear students. Let's take some simple examples. After this, you will never ever be confused. So these are my vectors, and I want to split it into two components. So, yep. So there will be components like this. This will have component like this, and like this. Oops, like this. This will have component 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 like this. Okay, and let's take some values. This is 10, this is 20, this is 30, this is 40. Okay, this angle is 30 degrees. This angle is 60 degrees. This angle is, let's say, 45 degrees. Let's say this angle is 50 degrees, chumma, some random angles I have taken. Okay, so what will be the components in each case? Let's try to figure it out. First of all, check this, my dear students. Okay, I'll do it on the next slide. This angle is closer to this component, so this component will be cos. So this will be, oops, this will be 20 cos 45. Got it? 20 cos 45. This is far away, so this will be sine component. So 20 sine 45. Sine 45 is 1 by root 2, so it will be 20 by root 2. This will be also 20 by root 2. Is that okay? If somebody asks me what is the actual value of the vector in this case, this will be 20 root 2. Okay, observe this. It will be 20 by root 2 I cap, because it is in the x direction, and this is in the y direction. So 20 by root 2 into j cap. So that is how you write this particular vector quantity. Is that absolutely clear? Yep. Everyone? Yes, Harshit, you will be getting the lecture PDF. Now let's do it over here. This angle is closer to this component. So close means cos. So this will be 10 cos 50. Cos 50, I don't know. Just leave it as it is. This is far away. So this will be 10 sine of 50. If you ask me, how will you write it in vector form? Well, the x component is in the negative x direction. So this will be technically minus 10 sine 50 I cap plus, because it is in the plus y direction, plus 10 cos 50 j cap. So that is the total vector, how it is represented. This is how, once you split the components, you can put it up over here for adding the vectors, whichever they are. Same thing over here. Let's do it. This is closer, so this will be nothing but 30 cos 60. Cos 60 is half, so it will be 30 multiplied by half. So it will be just 15 units. This is far away, so this will be nothing but 30 sine 60. Sine 60 is root 3 by 2, so it will be 15 root 3. So if somebody asks you what is that vector going to look like, well, in the x direction it is negatively oriented, so it will be nothing but minus 15 root 3 I cap, and in the y direction it is negative again, so minus 15 j cap. Is that okay, my dear students? Both are going to be negative. Similarly, over here, my dear students, this 40 will be split into two components. This is the closer component, so this will be 40 cos 30, and this will be nothing but 40 sine of 30. So sine 30 is half, so it will be 20. This cos 30 is root 3 by 2, so it will be 20 root 3. So if somebody asks you what is the total vector in IJK notation, unit notation, in x direction it is positively oriented, so 20 root 3 I cap. This is in the negative j direction or negative y axis, so minus 20 j cap. So that's how to take any vector, split it into components, and write it in its unit notation, which can be further used for addition, subtraction, multiplication, whatever it is. Okay, Lakshmi, noted. Your point is noted. We will definitely look into it. If you want AEEE exam related mock, please leave it in the comments. We will try to see when we can conduct it. Okay. Now there is a beautiful question which comes in Newton's laws and all of it, and there you often need to split vectors, add vectors, and lot of other things you need to do. So say for example, our problem is something like this, where you have a block and let's say it is on an inclined plane, and you might have seen something like you draw the forces acting on the block. You basically show the forces acting on the block, and this inclined plane might be making some angle over here, let's say theta, with respect to the horizontal. Then when you show the forces acting on the block, the forces of, which are acting on the block, the forces will look like this. One force will be probably the weight, and the weight force is usually mass into acceleration due to gravity. Weight is a force, which is m into g. Then the surface on which the block will be resting on will support it by offering a reaction force, that is also called as the normal reaction, or just I can call it as R or N, whatever you want to call it. Okay, and maybe there might be some kind of friction between the block and the surface. So the block might want to go down. The friction will prevent it from slipping downwards. So, you might have some kind of a frictional force like this acting between the two surfaces. So usually these are the forces which act on such bodies or such problems. And this is a very, very important type of question. Usually students get confused how to split the vectors. Forces are vectors. I have to split it. So you tell me naturally what is coming into your mind, that should I split R or F or mg? Or should I split all three? Or should I split only R and F to solve any kind of thing? Or should I split only mg and F, or mg and R, or just mg? What is coming onto your mind? Come on, my dear students. Come on, my dear students. What is coming onto your mind? In general, like, see, everything, if it is perpendicular, it is easy. Like going up, left, down, this, that, everything, if it is like this, it is easy. But if it is like this, like this, like this, like this, like this, it is difficult. So up, right, left, like this, if it is there, then things are easy. That means every angle should be perpendicular. So already I see this reaction and friction are perpendicular to each other. So do not do anything to it. This mg fellow is at a weird angle. So splitting that will be the smart move. So mg, I will split it up into two parts. I can say mg is composed of one force here and the other force here. Now usually people get confused which one is what. Is it mg cos or mg sin? So I have a beautiful technique, guys, and the technique is division by 8 method. What you do is you show the inclined plane and show the perpendicular. What do you do? Show the inclined plane, show the inclined plane, and show the perpendicular to the incline. Next thing what you do, also show the actual horizontal and the actual vertical. This is also important. The actual horizontal, that means like this, perpendicular to gravity, and vertical is in the direction of gravitational acceleration. So this is your true vertical, how you would normally stand without leaning onto the higher side. That's it. Your job is done. You have divided it into 8 parts. 1, 2, 3, 4, 5, 6, 7, 8. Now see, guys, the angle of inclination is theta. That means between the inclined plane and the horizontal. Between the inclined plane and the horizontal, the angle is theta. Leave every one part and go to the alternate part and mark that as theta. Theta, 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 theta. All these are thetas. It's very simple, guys. That is how you can mark all the angles. So whichever angle is given to you, okay, this is inclined, this is horizontal. So angle between inclined and horizontal is theta. Leave one part, go to the next part. All those alternate angles will be theta. Is this absolutely correct? Okay, perfect. Now look over here. You will quickly understand what I'm trying to say. See, guys, inclined is there, perpendicular is there, inclined is there, perpendicular is there, horizontal is also there, vertical also there, vertical is also there. Now think, guys, which angle do you know out of all these things? Which angle do you know? Angle between inclined and horizontal, isn't it this particular angle? This particular angle is theta. So obviously this is theta, obviously this is theta, and obviously this is also theta. That's it. Your job is done now. This theta is closer to this component. So this will be mg cos theta. And this component is far away. So that's why this will be the sine component, mg sine theta. That's how you use vectors, splitting, addition. Yeah, everyone with me, you will never ever get confused after this particular method. All right, perfecto. Yeah, yes, I know. May 7th, AEEE will look into it. Okay, thank you, Arshit. Sir, please post sessions for class 12. We want a long-term course live from you. Yes, definitely, Prasad, definitely. And guys, I'm also interested to know, do you want a proper batch also for the next 1 year, which will tackle JEE Mains and JEE Advanced with test series and notes, and your JEE English teachers, obviously supported by our pro teachers as well? Do you want us to do something for a long-term basis? Please let me know in the chat box. If you are putting it in the comments, then definitely we'll look into it. So whenever you have these kind of questions, many forces, chumma, forget what is this friction, normal, mg. These are three. The blue ones are the forces. I wanted to get rid of mg. Instead, I wanted two components of mg. So those pink ones were the components of mg in the perpendicular directions, because once they are perpendicular, I can take care of this direction separately. I can take care of this direction separately because they are perpendicular to each other. So I didn't know who is mg cos or mg sin. The trick is show horizontal, vertical, incline, perpendicular to the incline. Whatever one angle you know, leave one side, go to the next, leave one, go to the next, leave one, go to the next. Every alternate angle is theta. Next thing, over here, this was theta, that means this is theta. So if this is theta, leave this, this is theta, leave this is theta, leave this is theta. So the component which is closer is cos, the component which is far away is sine. That is what I had told you when I had talked about components. Is this now absolutely clear? Okay. Thank you, Afzal. Okay. Right, Kishore? Yep. Okay. IBU, it's completely up to you. You are free to watch as many lectures as it takes to understand a concept. If you are happy with the batch that you are, please continue. No need to watch. But if you are finding it difficult in something, then obviously I would recommend, highly recommend watching my classes, because you will find every single content related to JEE on this channel of mine. All right, cool. Now that you have understood this, many times in Newton's laws, you will see fair application of, vector addition, subtraction, and all of that. So say for example, there is a box, and let's say here are the following forces acting on it. One force here, one force here, one force here, one force here, another force here, another force here. Okay, Chuma, I have put some random forces. Let's say this is 2 Newton. Let's say this is 3 Newton. Let's say this is 4 Newton. Let's say this is 5 Newton. Let's say this is 6 Newton. 6 Newton. Let's say this is 2 Newton. Okay, Chuma, I have put some random forces. Now I ask you, can you find out the net force because of all these forces acting on this box? Obviously we can, but what will we do? To simplify, to solve it quickly, whatever is there in the upward, downward, we will solve it separately. Whatever is there in the left, right direction, we will solve it separately. So if you think in the upward direction, in the y direction, the force will be, check this out, 5 is in the upward direction, so plus y, so positive, so plus 5 is there. Then 6 Newton is there downward, so I'll put minus 6. This 2 Newton is there downward, so minus 2. So 6 and 2 is 8. 5 minus 8 is how much? 5 minus 8 is how much? Minus 3. So minus 3 Newton. What is this minus 3 telling me? It just means that if I ask you Fy bar, then it is negative 3 J cap Newton. So it is in the downward direction, the net force in the y direction. Similarly, if somebody asks me what is happening in x, right side is positive, left side is negative. 2 Newton is in the x direction, so plus 2. 3 is opposite, so minus 3. 4 is in the positive, so plus 4. 2 plus 4 is 6. 6 minus 3 is again 3. So this is just going to be 3 I, or just I can say 3 Newton. But if you ask me what is Fx bar, I will say it is 3 I cap Newton. Is that right? Everybody? Oh, so what is the net force, sir? What is the net force, sir? The net force is Fx bar and Fy bar both together. That means it is 3 I cap and also 3 J cap Newtons. That is the net force. Because this is 3 and 3 both together, that means 3 in this direction, 3 in this direction. So the net force on that, the net force on it is somewhere like this. Net force on it is basically somewhere like this. See, this is how your net force will be. Net force will be 3 I cap, 3 J cap, somewhere in the northeast direction. If somebody asks you what is the magnitude of that net force, well, you will just take the components. So 3 and 3, square it, add it inside the root. That's it. So 3 square and 3 square is 9, 9 2 times. So this will be nothing but a 9 multiplied by 2, which is nothing but 3 root 2 Newton. So that is the net force acting on this particular mass. Now, just imagine they tell you, hey, listen, the mass of this guy, listen, the mass of this particular guy is, for example, they say it is maybe 6 kg or something. 6 kg or something. We all have heard about the Newton's famous law. We have all have heard about the Newton's famous law, and that says, what does it say, my dear students? Whatever is the net force, that is equal to the mass into acceleration of that particular body. Mass of that particular body multiplied by acceleration of that particular body. This is by Newton's law of motion. This is by Newton's law of motion. Everybody fine till this point? Correct? Very good. Yes. Awesome. Now, Harshit, you need our Cap2 Plus Prime batch in pure English. Okay. So if you need a pure English batch, especially for all the students in South India or major cities, Northeast, even abroad, then leave a comment after the session is over. I would be delighted if you want it. Okay. I will make something for you only if you comment. If you don't comment, then it will just be something normal then. Okay. So coming back, do I know the net force to find the acceleration of the body? Yes, I just figured it out. The net force was nothing but 3 root 2 Newton. Oh, it was 3 root 2 Newton. Do I know the mass of the body? Yes. Can I find the acceleration of the body? Of course, why not? So 3 root 2 divided by 6, which is 3 by 6 is 1 by 2. So this will be root 2 divided by 2, which is root 2 divided by root 2 into root 2, because 2 is root 2 square. So root 2 cancel. So A will be 1 by root 2 meters per second square. So that's how you can find the acceleration when multiple forces are acting. When multiple forces are acting, this is how you can find the acceleration, my dear students. Is this absolutely clear? Oh, I had to put minus 3j. I think I missed that minus sign. So sorry. Yeah, this was minus 3. Yes, this was minus 3j cap. Yes, 3I cap minus 3j cap. But when you square it, it doesn't matter. The magnitude will be the same. Correct. Cool. So that was vector addition. That was vector addition and its applications. Are these the only applications possible? No. There are so many other applications which you will be seeing in so many problems. Like, for example, we all know that like charges repel and unlike charges attract each other, isn't it? So we know that like charges will repel each other, and unlike charges will attract each other. So there are so many questions on vectors you will see in the first chapter itself. Say, for example, you might get a question with triangle, or you might get a question with a square, or you might get a question with hexagon. Now, let me show a hexagon. To you. Okay. And you might be given some charges somewhere here and there. So let's say there is a positive charge here, there is a negative charge here. Okay. And then they might ask you, what is, if there is another positive charge here, what is the force on this guy? So we know that positive and positive like charges will repel. So these two charges obviously will repel each other like this. So there will be a force like this in this direction. Positive and negative unlike charges will attract. So there will be a force like this. Let's say I call it F2. So the vector addition of both of them, can you guess, guys? Use your triangle law, whatever law you want. Yes, use your triangle law, parallelogram law. I think parallelogram will be easy over here, or use your analytical method, and quickly you will notice that the net force is over here. This is basically then the net force in this particular case, isn't it? So the resultant force on this guy will be somewhere on this side. That's how you can solve the question. Similarly, you can have more questions like this. Say there is a positive charge here, negative charge here, positive charge here, and maybe another positive charge here. Okay, and the question is, figure out where the net force is on, let's say, this particular charge. On, let's say, this particular charge. So what will you do? Positive and positive will repel. So 100%, this positive will put a repulsive force here. This negative will obviously attract, and this positive will obviously repel. So now you have three forces together and you have to find the resultant. Actually, these two forces are mutually perpendicular to each other. They will produce a resultant somewhere in this direction, and then you can add that with this. So that's how you can solve the question. You have three forces, solve them by simple vector addition. Similarly, you can have a question on, multiple things like over here. Maybe there is a central charge and you have to find the force on that charge. One positive is there here, positive, negative, negative, positive, positive. Some forces are going to act on this central charge. What is the net force going to be? Well, we all know positives will repel the positive. So this positive will repel this positive. This positive will also repel this positive. This positive will also repel this positive. This positive will repel this positive. This negative will attract it. This negative will attract it. Everything is cancelling. So the net force in this case obviously will be zero. Net force in this case will be zero. So things like that, you will see it in the electrostatics chapter. Is that right? Okay, looks like benzene. Yep. The session PDF will be available in the comment section after the session is over by tomorrow. Usually it takes a 1 day time maximum, okay, for the session PDF to be updated. Oh, yes, sir. Finally, I understood what is this vector addition all about. So we need to know components. We need to know vector addition for solving these questions. Now, you also need to know Newton's laws, which I just showed it to you right over here. Mass into acceleration is always the net force. So sometimes the net force might not be in the direction which you want. Maybe it could be at an angle also. So sometimes you might see that there is a force here, maybe there is a force here, and let's say there is another force here, okay, maybe making some angle over here like this, or maybe like this, okay, and the forces are, let's say this is 2 Newton, this is 2 Newton, and let's say this is I don't know, maybe 6 Newton or something, and this is making an angle of 45 degrees. And there is example a mass over here whose mass is, let's say, for example, 4 kg. Can we solve this problem and figure out what is the acceleration of that mass? Can we solve this problem and find out the acceleration of this mass using Newton's law, F is equal to ma? First, find the net force. Now think logically. Is it good to split 6 Newton and then add and then find the resultant? Or can you do some mental trick? Can you see something which can make the problem little easier? And I think there is. I'll tell you how. This 2 Newton and this 2 Newton, if I club them together, okay, if this 2 Newton and this 2 Newton, if I club them together, I will get one single force. I will get one single force making angle 45 degrees. This is 2 Newton. This is 2 Newton. Their resultant will be making equal angles on both the sides. How much will be that resultant? Well. If you notice very carefully, the resultant will be here. The resultant will be here. Use Pythagoras theorem, my dear students. This particular resultant will be root of 2 square plus 2 square, which is basically 2 root 2 Newton. Oh, so I can get rid of these two forces and combine it as a single force. Now just show that singular force. How much was it? 2 root 2 Newton. And this force 6 Newton was still remaining, correct? This force of 6 Newton was still remaining. So just place it here. So this was 6 Newton. Now these are the only two forces remaining because I have got rid of these two forces, combined it into one singular force. And the best part, they are opposite but not equal. That's okay, even if they are not equal. This is 45 degree, this is 45 degree. That's why they are perfectly opposite to each other. So how do I solve them now? Well, the net force, needless to say, net force now, the bigger force minus the smaller force, so 6 minus 2 root 2 Newton. That's it. And we all know what to do with net force. Whenever we have net force, that is mass multiplied by acceleration. So net force is 6 minus 2 root 2. Mass is 4 kg multiplied by acceleration. So divided by 4. So 6 by 4 minus 2 root 2 divided by 4. So therefore the acceleration will be 3 by 2 minus root 2 by 2, which is 3 by 2 minus 1 by root 2 meters per second square. Meters per second square. That is the answer. Okay. Yes, there is a long-term batch coming up very soon. And you welcome. You are a member of the channel. Wow, nice to see our members over here. Okay, great. Great. Prasad, definitely it is coming. Right. A road series for 2026. All right. Cool. No, I'm not doing till waves. I'm just doing the essentials which are going to need for starting your 12th standard, because that is very important, because most students often find a big mismatch when they enter 12th and they have forgotten. So it's a very good, recap of all these chapters so that you are up to speed. That's all. Okay, cool. Now, if you want special classes of 11th one shot, we can do that in the next coming days. Okay, now let's do this. Let's do the next thing which you will be needing. Fine, you will be needing Newton's laws. You will be needing vector additions. You will be needing the concept of vectors and all of this. Do you know how to find a unit vector in a direction? That is also very, very important. How to find a unit vector in a direction. How to find a unit vector in somebody else's direction. So just imagine this particular problem now, where you have, let's say, some vector. I will call that vector as V. I want to find V hat. What's the meaning of it? V hat means a vector who is in the direction of V bar, but the magnitude is 1 unit. Now this is a big vector, the magnitude is not 1. So vector whose magnitude is 1 but in the same direction might probably be like this. So maybe this is your V hat. Oh, okay. So is there any relationship between the two? Of course. This V hat, if I put it a number of times, V hat, V hat, V hat, like that, if I keep putting it, I will get the total vector V. But how many times should I put it so that I get the total vector V? Imagine this length. If I ask you, what is the length of this? What is the length of this? Immediately you will be like, sir, the length is the magnitude, so V bar. So if this is 1 unit, if this is exactly 1 unit, 1, 1, 1, 1, 1, 1, how many times? Magnitude times. You will put it how many times? Magnitude of the vector times. So V bar mod times V hat will give you V bar. So therefore, V bar divided by the modulus of V gives you V hat. This is also used in the vector representation of Coulomb's law. You will be seeing it very soon. Is that right? Is that right, everyone? Yeah. The lecture is going to be till 7:15. Okay. The lecture is going to be till 7:15. Now, I'll give you an example of this. Say my vector is, say for example, minus 3 I cap plus 4 j cap. The question is, can you quickly find V hat? The question is, can you quickly find V hat? Okay, let's try to find V hat from this. By definition, V hat should be V vector divided by V modulus. V vector is this vector itself, so minus 3 I cap plus 4 j cap. and then V modulus is the modulus of this vector. So it will be root of, remember, that's how you find magnitude. Take the component, square it and put it inside the root. So this will be minus 3 I cap plus 4 j cap. What is this? 3 square is 9, 4 square is 16. 16 plus 9, 25. Root of 25? Yes, that's 5. So this will be nothing but minus 3 by 5 I cap plus 4 by 5 j cap. That is V hat. Now let me give you a feeling of this, what it exactly means, because with that only you will get proper feel of the physics. Minus 3 I cap plus 4 j cap. Minus 3 I cap is basically here, plus 4 j cap. Minus 3 I cap plus 4 j cap means over here. So that's how it is. So that is my total vector V. So that is my total vector, which is V bar. How much were the components? This was basically minus 3 I cap and this was basically plus 4 j cap. Now unit vector in that direction means just this much, whose length is, or the magnitude of that is 1. What we have done over here is just found out the components of it. That means this much part and this much part. So this one over here is minus 3 by 5 I cap and this one over here is 4 by 5 j cap. So minus 3 by I cap and plus 4 by 5 j cap together gives me a unit vector whose length is 1 in the direction of V. That is what technically you have done. Is that absolutely clear? Is this absolutely clear? Okay, everyone? Cool? Great. Now, lastly, let me also tell you that you will also need the knowledge of kinetic energy and work and potential energy, okay, in the chapter of electrostatics, potential, capacitors and all of that. So remember, work is basically force in the direction of displacement multiplied by displacement itself. So if you have a force which is directed like this, and let's say the displacement is somewhere over here, making some angle, let's say theta, then the work will be force in the direction of the displacement. Immediately you should be able to figure out, yes sir, we are talking about the component of this. Do not worry about this component. Forget that. Just look at the component of the force in the direction of the displacement. That means F cos theta. So force in the direction of displacement means F cos theta multiplied by the displacement means it is just going to be S. Yes, this work is a scalar quantity, and the SI unit is basically a joule, and joule is nothing but a Newton multiplied by a meter. Newton multiplied by a meter. A Newton of force dragging it by a meter of displacement gives you a joule of work. It's a scalar quantity. It is F cos theta multiplied by S. You will need this for work done. Okay, keep this in mind. All right. Now you will see that force is a vector, displacement is a vector, and when you are multiplying two vectors to give you a scalar, that is called as the scalar product. So the scalar product came into effect because of physical quantities like work, power, and so many other things, where the scientists, the engineers, the physicists saw that every time there was a trend in many physical quantities where you multiplied two vectors, but the outcome was a scalar. So they called it as a scalar product and they defined it with a symbol called as dot, and you put one vector which is multiplied on one side and the other vector being multiplied on the other side. So this is also called as scalar product, or basically dot product. Dot product. So the dot product or the scalar product of two vectors is always a scalar, and the value of that scalar is force in, or one vector into other vector, one vector into other vector, into the cosine of the angle between them, into the cosine. So the dot is like the cos over here. The dot is like the cos, it's not the cos, it's like the cos of the angle between the two vectors. That's what it symbolizes. You will need this in the calculation of work. Okay. Now, also remember there are different kinds of forces based on how they work. Yes, there are different kinds of forces based on how they work. So you will see there are a category of forces where if the body is going along a path but it is returning back to the same point, this is called as a closed path. Closed path, and continuously there is a force acting on it. Maybe the force is like this, then like this, like this, like this. Every point it is doing the work, but it is found that the total work done in that closed path is always a zero. Then such a force which is acting, that particular force is said to be conservative force. Conservative force. It is said to be conservative force. Examples are gravitational force, electric force, spring force, your elastic force. All these forces are conservative in nature. And one beauty of conservative forces is also that apart from the total work, when you come back is zero, that means gravity. If there is a mass, I push it, move it here, there, like this, like this, like this, and bring it back to the same point, the gravity would have done zero work when I brought it to the same point. So another beauty is that if I go via one path to some place, so this is my initial point, this is my final point, via some path labeled 1 versus some another path like this labeled 2, the work done via the first path is equal to the second path or even the third path. Basically, the work done doesn't depend on the path. Whatever path you take, so I take a mass, I move it like this, like this, like this here, or just like this, or just like this. As long as initial and final locations are same, how you reach there doesn't matter. The work done will be the same. But then there are these other forces where you bring it back to the same point in a closed path, and that particular force which is acting is non-conservative if you find out that the total work done in that closed path is not zero. So then that force is non-conservative, is non-conservative force, is non-conservative force. Example forces like friction, normal, tension, the pushing, pulling force, all these, drag force, air resistance force, all these are non-conservative forces. So their work done will also not be the same. So if somebody decides to go via this path, which is path labeled 1 versus path labeled 2, the work done via path 1 will not be the work done via path 2. That is what will happen. Is this absolutely clear, my dear students? Yep. Okay, great. All right. So, these are the things that you will need, because electric force is conservative. You will be using this concept many times. Now, I want to know from you many questions, guys. Actually, see, there are a lot of things because you guys are new to me. I'm also new to you. I want to know a lot of things. And the more the students comment, trust me, Shreyas Sir always goes with the students. You would have seen that students who commented BitSat, I will be conducting BitSat. Before this, students said VIT triple E, VIT triple E. Okay, KCT, KCT, Comet K, Comet K. So we go with the flow, guys. Understand? And that is very important, because what you want, I might teach something, but you are like, sir, now exams are not there. That is there. I need that. Fine, we'll do that, because that is the majority's priority. Okay, so I want to know a couple of things from all of you. Do you want like a formula or concept revision of 11th most important, or basically all the high and important concepts? Do you want that before we begin the 12th, or do you want, like, you want to directly start the 12th standard? Okay, all these are questions I am asking you. Okay, do you want to start with some kind of a mock test, or basically something like a check yourself how good you are with your 11th, and you will be like, no sir, we don't want to check ourselves, we know we are wasted, please skip this, don't even test us. Okay, just go with the formulas or concept. That is also fine, no problems, no issues, let's be frank. Okay, or do you want any particular chapter, or basically any particular unit, or topics one shot before we progress to the 12th standard? So these are some of the questions which I'm asking. And apart from that, one major question: do you want a long term dedicated batch, okay, where you have every lecture in English with tests, assignment, everything, assignment, live classes, everything, so all the other things, like a proper batch, but cheap batch? Okay, do you want that? So all these things, please answer in the comment section. Cool guys, I hope you revised a lot in today's class, and all the things which I have told you over here, they will be available as notes in the PDF format. And yes, you also have the JEE Pro batches also, which are live right now. You can check out the link which is there in the description box. These are our batches for all our long-term students, and all the links will be there in the description box. Okay, first of all, please remember, we will be coming to Chennai this particular next week on 6th of May. That link also have posted over here. I think somewhere here might be there. If it is not there here, it's there on the channel, guys. Just check this out. Where is it? In the video section. In the video section, it will be there. Attention Chennai. So that link is there over here. Please register for the event. Okay. Counseling in Chennai. This link is there. Fill up this form and be there, because the number of seats are limited. Okay. Cool guys. See you. Answer all the questions. Whatever questions you have in mind also, that's perfectly fine. You can let me know in the comment section. Do not forget to smash the like button and subscribe to the channel. Bye bye. Take care.